All right, so here we are in question 1. It's a trigonometric graph style question. We've got a graph of a cos bx plus c. We want to find out what a, b, and c are. Now, the key to doing this is really to understand what is meant by a, b, and c. And I'm going to start with c, I think. It's the easiest one to understand. C is the shift in the y direction. And it kind of tells you where the center line of your graph is. Now, what do I mean by the center line? I think it's just easier if I draw it on and show you in this case. This is the center line. Right, so that's the line around which the whole of our graph is centered. Now, how could I find the location of that line? Well, I can take my peak value, which is 2, and my minimum value, which is -6. If I add those up and divide by 2, it's going to give me the y-coordinate of the center. So 2 plus -6 is -4, divided by 2 is -2. So this is my center line, which means that C is equal to -2. Okay, then, well, having done that, probably finding A is the next easy thing to do. What's A? A is the amplitude. And the amplitude is the distance from the center line up to the peak, or the center line down to the trough. Okay, and what's that distance? Well, it's going to be 4, right? That distance there is 4, so A is equal to 4. Okay, now the last one, this B is the thing that causes students, in my experience, the most difficulty. Okay, what does that B mean? B refers to the number of waves in 360 degrees, right? So the number of waves in 360 degrees. Okay, so for example, if we've got cos 3x, that means there are 3 waves in 360. If we've got cos 5x, it means there are 5 waves in 360. If we've got 10x, it means there are 10 waves in 360. What that means, therefore, is we're able to find out the size of each wave, which is what we call the time period, by doing 360 divided by that value of b. Right? So, for example, if we've got cos 3x, it means that there are 3 waves in 360. So each wave is going to be 360 divided by 320. That means that if we want to find b, we can just rearrange this equation. We can get b is 360 degrees divided by t. Okay, and so we can look at our graph and say, well, what's the period? What's t? Well, the whole wave starts at -480, goes all the way to +480. So t is 2 times by 480, which is 960. And so our b in this case is going to be 360 degrees divided by 960. Of course, we can cancel, can't we? So we've got 36 over 96. We can divide top and bottom by 3. So it's 12 upon 32. And then we could, divide by 4, I think. That would give us 3 over 8. So our b is 3 upon 8. So let me just clarify that. What's our a? A is equal to 4. That's the amplitude. What's our b? 3/8. And what's our c? C is equal to -2. Okay, guys, I've taken a little bit of a longer time there to explain that, but I often find that students really struggle to understand, particularly the thing with b. So what I encourage you to do is try to get it into your head. What are these a, b, and c things, right? A is amplitude. B is the number of waves in 360, and C is the shift of the center line of your graph. Okay, so here we are in question 2, which is a surds question. We're supposed to solve this particular equation here, which is a quadratic. So I think the first thing we want to do is want to rearrange it to make it more clearly a quadratic. So we're going to get here 2 plus root 5x squared. So 2 plus root 5x squared minus 4x minus 3 brackets 2 minus root 5. Okay, and this is a quadratic equation here, where this term here is our a, 2 plus root 5. Our b is -4. We've got to be very careful about that. It's -4. And our c is minus 3 times by 2 minus root 5. So I think it's probably a good idea just to write that out so we're super clear. So a is equal to 2 plus root 5. Our b is equal to -4, and our c is equal to -3 times by 2 minus root 5. Well, I'm just going to rearrange that a little bit. I'm going to write it as 3 root 5 minus 6. Now, in order to solve this, we've got to use the quadratic formula, right? For those of you who've forgotten the quadratic formula, that is this. X is equal to minus b plus or minus the square root of b squared minus 4ac, all divided through by 2a. Now, what I would suggest is that you break this problem down and you consider the b squared minus 4ac first. Because the thing is, right, if you try to include all of the algebra in one line, then it gets very long, it gets quite confusing, and the chances of you making a mistake, I think, are quite high. So we're going to deal with the b squared minus 4ac first. So let me just do that. B squared minus 4ac is equal to negative 4 squared, which is positive 16, minus 4 times by 2 plus root 5 times by c, which is 3 root 5 minus 6. So now let's expand this. We've got 16 times by minus 4, big bracket. So I'm going to now expand these brackets here. I'm going to get 2 times by 3 root 5, which is 6 root 5, and then 2 times by minus 6, which is minus 12. Root 5 times by 3 root 5. Well, root 5 times root 5 is 5. 3 times by 5 is 15. And then we've got root 5 times by minus 6, which is minus 6 root 5. Okay. Now, one of the things we can notice, very convenient, is the 6 root 5 and the minus 6 root 5, they cancel off. So what we're going to be left with is 16 minus 4 bracket, negative 12 plus 15 is positive 3. And so 4 times by 3 is 12, and 16 minus 12 is 4. Now, I would say in questions of this type, usually you would expect the b squared minus 4ac term to have no square roots, and very often it leaves you with a square number. Okay, if you haven't got that, I suggest you go back and redo it when you're doing similar questions of this type. Okay, so now we've got that, so we can complete the rest of our quadratic formula. X is equal to minus b, so that's minus 4, plus or minus the square root of b squared minus 4ac, and we've just said that that is 4, all over 2a, and a is 2 plus root 5. Got 2, bracket, 2 plus root 5 there. Okay, well, let's try to tidy this up, I think. So minus 4 is positive 4. And the square root of 4 is 2. And I think we can also say, why don't we divide top and bottom by 2? So if I divide the top by 2, I'm going to be left with 2 plus or minus 1 over 2 plus root 5. Now, at this point, I notice students, they try to rationalize with this thing here. I just think it ends up with being such a colossal mess. So I would strongly suggest that what you do takes you a little bit more time, but just split this up into two separate ones. Okay, so what we're going to say is we've got x is equal to 2 plus 1, which is 3 over 2 plus root 5. And we've also got x is equal to 2 minus 1, which is 1 over 2 plus 5. And then what we're going to do is we're going to rationalize both of these. And the way we rationalize is we multiply top and bottom by the conjugate. What I mean by the conjugate is if you've got 2 plus root 5, the conjugate is going to be 2 minus root 5. Okay, so we're going to multiply top and bottom by 2 minus root 5. Okay, well, if I do that on the top of this one, I'm going to get 3 times by 2, which is 6, minus 3 root 5. And on the bottom, I'm going to get 2 times by 2, which is 4, 2 times by minus root 5, and then root 5 times by positive 2. Well, those things are going to cancel out because it's minus 2 root 5 plus 2 root 5. And I'm left with root 5 times by minus root 5, which is minus 5. So here what I'm going to get is 6 minus 3 root 5, all divided through by negative 1. And of course, that can be simplified to give minus 6 plus 3 root 5. Right, so that's one answer. And of course, we can do the same thing over here with the second answer. We've got to multiply top and bottom by the conjugate again, 2 minus root 5, 2 minus root 5. And if I do that, then on the top, you get 2 minus root 5. On the bottom, what you're going to get is the same thing, negative 1. And so that simplifies to give minus 2 plus root 5. That should be your two answers, minus 6 plus 3 root 5 and minus 2 plus root 5. Okay, then here we are in question 3, which is a polynomial type of question. The diagram shows the graph of y equals modulus f of x, where f of x is a cubic polynomial. We want to find in factorized form the possible expressions for f of x. Now, the key to doing this question is to understand the factor theorem. What is the factor theorem? The factor theorem states that if x equals a is a root of a polynomial, then x minus a is a factor of the polynomial. Okay, that is really the key thing. So what does that mean? Well, if 2 is a root, x minus 2 is a factor. If 3 is a root, if 3 is a root, x minus 3 is a factor. If 5 is a root, x minus 5 is a factor. Okay, so here what we've got to do is we've got to identify our roots. Now, what are roots? Roots are basically x-intercepts. So we've got a root there at -2, root here at +1, and a root here at +4. So we're going to write those things down. So we've got roots at x is equal to -2, x is equal to +1, and x is equal to +4. And therefore, we've got factors with x minus -2, so x plus 2, x minus 1, and x minus 4. And if that is the case, then we should be able to write our graph as the modulus of x plus 2 times by x minus 1 times by x minus 4. And the thing that I think a lot of students are going to forget is we need to include a constant here, a k. And the reason for that is we don't know whether we've got a 1x cubed or a 2x cubed or a 3x cubed or even a negative x cubed. So now what we've got to do is we've got to find out what that constant is. How are we going to do that? Well, if we look at our graph, we also know the y-intercept. Right? We know this point here. And that's the point where x is equal to 0 and y is equal to 24. So we can substitute that into our equation here. So when y is equal to 24, we know that x must be equal to 0. So we are going to have 0 plus 2, which is 2, 0 minus 1, which is -1, and 0 minus 4, which is -4. Okay, and we look inside that. We're going to have k, 2 times by -1 times by -4 is going to be +8. And that's going to be equal to 24. Well, that means that we've actually got two possible outcomes for k, right? K can either be equal to +3, or it could be equal to -3. Because if you think about it, if k was equal to -3, then inside the modulus, what we would get is -24. Then a -24 with a modulus on it becomes +24. All right, so that would all be fine. Okay, so if we conclude our polynomials could be y equals mod 3 bracket x plus 2, x minus 1, x minus 4. Or alternatively, it could be y equals mod -3, x plus 2, x minus 1, x minus 4. Both of those options, totally fine. Okay, then part B, we need to solve an inequality. Now, I think the best way to solve a inequality with the modulus sign is just to square both sides. So that's what I'm going to do. I'm going to have here 5x minus 2 all squared is less than or equal to 4x plus 1 all squared. So we're just going to expand both sides. 5x times by 5x is 25x squared. Then 5x times by -2 is -10x. But we're going to have that repeated. So we've got -20x. And -2 squared is +4. Less than or equal to, well, 4x times by 4x is 16x squared. 4x times by 1 is 4x. We've got two of those, so it's 8x. And 1 times by 1 is 1. And let's put everything through onto one side. So 25x squared minus 16x squared is 9x squared. Minus 20x minus 8 is minus 28x. And 4 minus 1 is 3. Okay. All right, well, I can't see an easy way to simplify that because you can't divide that 28 by 3. So I'm going to try to factorize this. So let's say we've got 9x there, and x here. Okay, now what we're looking for is we're looking for two numbers that are going to multiply together to give +3. They're going to add up to give -28 and I think probably the numbers that will come to my mind is going to be minus 3 and minus 1. Now, if we just think about that for a second, we're going to get 9x times by minus 3, which is minus 27, and minus 1 times by x is minus x. So you combine those, you get negative 28x, and minus 1 times by minus 3 is positive 3. Okay, now this is the part where I think most students are going to get stuck because they're not going to sketch the graph. Now, I think the best thing for you to do is to try to sketch out what this graph is going to look like. So I'm going to do that below. Okay, so here, oh, sorry, beg your pardon. That. What we have here is we've got a quadratic, and the roots of this quadratic are going to be at 1/9, okay, and at 3 over here. If I was to draw this quadratic, if I was to draw it all out, that's what the quadratic would look like. Sorry about the roughness of the sketch. That, like that. Okay, and then we're asking, where is this quadratic less than 0, right? In other words, where are the y values less than 0? And the y values are less than 0 here, right? Everything there. Okay, so what are the x coordinates to give us that? Well, everything from 1/9 all the way up to 3. So the solution to this is that x must be greater than or equal to 1/9. It must be less than or equal to 3. And that's going to be the solution to our inequality. Okay, then here we are in question 4, which is a circular measure style of question. The diagram shows a circle with center O with radius r. The points A and B lie on the circumference of the circle such that the angle AOB is theta there. And the length of the minor arc AB is 12. Now, the minor arc means that thing from there to there. The major arc AB would be that thing there, right? So minor means the smaller. Now, we're told that this length here is 12, so I'm going to label that onto my diagram. That's 12. And we're also told that the area of the minor sector is 57.6. So this area here of that sector is equal to 57.6. Now, the point C lies on the tangent to the circle at A. Now, this means that this is a tangent, okay? And if that's a tangent, then this angle here is going to be 90 degrees, right? Because the tangent and the radius of the circle, these things are always perpendicular. That is a very important fact that I strongly suggest that you commit to memory because it's going to come up probably in quite a few questions. All right. The length OBC is a straight line. All right, so now we want to find the values of r and theta. Now, there are two formulas that we need for these circular measure style of questions. The first formula is that the arc length S is equal to r theta. The second formula is that the area of a sector is equal to a half r squared theta. Well, we know that the arc length, 12, so we can write 12 is equal to r theta. And we know that the area of the sector is 57.6, so we can write 57.6 is equal to a half. And I can rewrite r squared theta as r times by r theta. Now, why have I rewritten it like that? Well, because we know that r theta is equal to 12. So what I can do is I can write here 57.6 is equal to a half times by r times by 12. Okay? Or in other words, 57.6 is equal to 6r. And if I do the division, divide both sides by 6, I get 9.6. So the radius of the circle is 9.6. And of course, what I've got to do is I've got to substitute into here. I've got to do 12 divided by 9.6 in order to find my angle. If I do that, I get 5/4 or 1.25 radians. Okay, then, well, part B of this question is we want to find the area of the shaded region. Now, how are we going to do that? Well, the area of the shaded region is the difference between the area of this triangle and the area of the sector. Now, we already know the area of the sector. That's the 57.6. So really the question is, can we find the area of this triangle? Now, the formula for the area of a triangle is a half base times by height. So if this length here, AC, is our base, okay, and this length here is our height, then we should be able to find the area of the triangle. Now, this length here is the same as the radius, right? That length is 9.6. So we already know that. So the question is, well, can we find the length AC? And the answer, of course, is yes, because we can just use some trigonometry. we can use the fact that tan theta, and theta here is 5 upon 4, is equal to the opposite side, AC, over the adjacent, which is 9.6. We can rewrite this and say AC is equal to 9.6 times by the tangent of 5 upon 4. Okay? All right, then, well, the area of the triangle should be quite easy to find. The area of the triangle will be a half the base, which is 9.6 tan 5 upon 4, times by the height, and the height is 9.6. Okay? So then if I want to find the shaded area is going to be this whole area here that we've just calculated. So a half, 9.6 times 9.6, so we can write 9.6 squared times by tan 5 upon 4 minus the area of the sector, which is 57.6. So we're going to subtract 57.6. Well, let me just put all of that into a calculator, I think. So I need to make sure that my calculator is set to radians. That is a common mistake, by the way. So I'm just going to set mine to radians. Good. So I'm going to do tan of 1.25, and I'm going to times that by 9.6 squared. Okay, and then I'm going to divide that by 2. And then finally, I'm going to subtract off 57.6. And if I do that, what I get is 81.1 centimeters squared to 3 significant figures. And so that should be the answer to that question. Okay, here we are in question 5. Now, I think the best thing to do with questions of this type is to use the substitution pretty early. So the substitution I'm going to use is to let u equal p to the power of a third. If I do that, this changes to 6u minus 5u to the negative 1 minus 13 is equal to 0. Now, what does u to the negative 1 means? It means 1 divided by u. This becomes 6u minus 5 over u minus 13 is equal to 0. And we're going to multiply the entire equation through by u to give us 6u squared minus 5 minus 13u. And hopefully what you can notice is that this thing is just a quadratic, right? So 6u squared minus 13u minus 5 is equal to 0. And it's a quadratic that we can either try to factorize, or we can use the quadratic formula for, or most of you got calculators that can also do this. I'm going to try, I think, to solve this with factorization. Now, if I was to open the brackets here, I could have 6u times by u, but I think it's probably more likely to be 3u and 2u. Now, what does that mean? I'm going to be looking for two numbers that multiply together to give negative 5. And they've got to combine in such a way that I'm going to get negative 13u here. So let's have a think about that. I think that's probably going to be minus 5 here and plus 1 there. Let's just test that out. Obviously, plus 1 times by negative 5 gives us negative 5. But if I've got 3u times by negative 5, that's minus 15u. And 1 times by 2u is plus 2u. So negative 15 plus 2u is negative 13u. Now, I'm sure there are some people here listening to that going, why on earth are you bothering to do that? You might as well just use a calculator. I think it's helpful, right? You always want to try to be competent at the maths you're doing. And you find if you're better at doing things like this, actually it helps you with all kinds of other problems as well. But I let that go. You can use a calculator if you want. I'm just showing you so you can see how I do it. Okay, now that's going to give us two solutions, right? The first solution is that I'll write it out in full. Either we've got 3u plus 1 is equal to 0, which means that u is equal to minus a third, or what we've got is that 2u minus 5 is equal to 0, in which case u is equal to 5 upon 2. Now, we haven't actually got the solution at this point because we know that u is equal to p to the power of a third. So what we're really saying here is that p to the power of a third is equal to negative 1 upon 3. And p to the power of a third is equal to 5 upon 2. So how are we going to find p? Well, we just cube both sides. So if I cube this, then what I'm going to get is negative, right? Because a negative times a negative times a negative is also negative. We get 1 upon 27, because that's 3 cubed. And here, if I cube this, I'm going to get 125 over 8. the solutions for our equation. Let's just check there are no conditions. Yeah, it doesn't say that p has to be positive or anything. So these are going to be our two answers. Okay, then part B of this question, which is a logarithmic equation. Now, I always think the key to doing these is to know the log rules. So I've written them here in case you've forgotten. So the first one is if I've got log A plus log B, that's equal to log A times B. I've got log A minus log B, that's equal to log A over B. And if I've got log A to the power of P, that's equal to P log A. Now, if we look at this equation, right, it's tempting to say, first of all, that we can use the second rule because we've got a log minus another log, but we can't do that. The reason for that is there is a number here, a coefficient for one of the logs. So when we've got that, we've got to deal with this thing first. The way we deal with that is we use the third log law. We convert the coefficient into a power. So what I'm going to do is I'm going to write this out as log 2x plus 5 to the power of 2 minus log x plus 2 is equal to 1. Now that I've done that, I can use the second log law and say that we've got log a minus log b, which is log of a over b. So we've got here 2x plus 5 all squared over x plus 2. Well, now that we've got this one single logarithm, we can convert it into exponential form, right? LG is log base 10. What we've got here is 2x plus 5 all squared over x plus 2 is equal to 10 to the power of 1, which is just 10. So now what we've got is really just a quadratic, and we just need to go through the algebra essentially. So we've got 2x plus 5 all squared is equal to 10 times by x plus 2. And if we do that, we can expand the left-hand side. So we're going to get 4x squared plus 20x plus 25 is equal to 10x plus 20. We bring everything through to the left-hand side to make our lives easier. We get 4x squared plus 10x plus 5. Now, usually I would try to factorize that, but this particular one doesn't factorize, so you need to use the quadratic formula. I know that many of you will use your calculators to do it. Can I just suggest to you, you must really write down on the exam paper, right, that you are using the quadratic formula. Right? If you just state the answer, then you may potentially lose out on method marks, right? So state out the quadratic formula because you want to demonstrate to the examiner that you know what you're doing, okay? All right, let's substitute in. So our b is 10. So here we're going to get b squared, which is 100, minus 4 times by a, which is 4, times by c, which is 5, all divided through by 2a, which is 8. Okay? Now then, let's try to simplify this. Negative 10 plus or minus square root of 100. 4 times by 5 is 20, times by another 4 is 80, so it's 100 minus 80 all over 8. I'm going to do this a little bit slower just to make sure that people follow the steps. So minus 10 plus or minus the square root of 20 all over 8. Now, 20 is what? 20 is 4 times by 5. So I can rewrite that as the square root of 4 times by 5. And therefore, I can square root the 4 to get minus 10 plus or minus 2 root 5 there. And then I can cancel off by dividing top and bottom by 2. Will give me minus 5 plus or minus root 5 all over 4. And that should be my answer. Okay, here we are in question 6, which is a trigonometry question and a trig identity question to be more specific. So here we are given that cot squared theta is equal to 1 upon y plus 2, and that sec theta is equal to x minus 4. Now, in order to do this question, we need to understand two bits of information. The first is that cot theta is equal to 1 divided by tan theta. And the other one is that sec squared theta is equal to 1 plus tan squared theta, right? If we've got those two bits of information, then we should be able to do this question. Now, first of all, with cot, every time we've got sec, cosec, or cot, if we struggle to remember, we need to look at the third letter. So let's just have a look at this. So 1, 2, 3. The third letter there is T. So cot is 1 divided by tan, right? And with sec, the third letter is C, so it's 1 divided by cos. And with cosec, the third letter is S, so it's 1 divided by sine. So that's a way to remember. This thing here, you don't need to remember. The reason you don't need to remember is it's given to you on the formula sheet on page 2 of your exam paper. So if you open it up, you should be able to see. Okay, then. Well, what we're going to do first is we're going to use this to rewrite this thing here. So instead of cot squared theta is equal to y plus 2, what we can say is 1 divided by tan squared theta is equal to 1 over y plus 2. And of course, if that's the case, we can say that tan squared theta is equal to y plus 2. Okay, so now we've done that. Well, now we can use the identity here on the right. So sec squared is going to be equal to x minus 4 squared. So we're going to write that out. We're going to have here x minus 4 squared is equal to 1 plus tan squared. And we just said that tan squared is y plus 2. In the end, we can rearrange this to get y is equal to x minus 4 squared minus 3. And there we are. We have just found y in terms of x. Okay, then here we are in part B of our trigonometry question. We are supposed to solve this particular equation here between negative pi and pi, giving our answers in terms of pi. Now then, the method I'm going to apply here is probably going to seem a bit long, a bit cumbersome to some of you, but the thing is with this type of question, I think it's really important to be nice, clear, and meticulous in our working. And the best way to do that, I think, is to be drawing a graph so that we really understand where each of our solutions is coming from. I know that I have many students who really like to use the quadrant method because they think it's kind of fast, shorter, easier. But one of the things I notice with students is that often because they don't really understand what the quadrant is all about, they end up guessing answers. And so sometimes they're right and sometimes they're wrong. So the method that I'm going to give you here is going to seem a little bit long. But the thing is, I think it's the easiest way for you to understand what's happening. And of course, if you understand what's happening, then you should be able to get the right answers. And that ultimately is the most important thing. So the first thing I'm going to do is I'm going to replace this 2 pi plus 3 pi upon 4 with another letter. So I'm going to say let theta equal 2 phi plus 3 pi upon 4. Because immediately that kind of simplifies the problem. We're now dealing with cosec theta is equal to 2 upon root 3, right? I've also moved the root 3 to the other side. Now, as I said in part A, with cosec, sec, and cot, we need to look at the third letter, right? So first letter, second letter, third letter is an S. So what we've got here is 1 divided by sine theta is equal to 2 divided by root 3. Well, okay, if that's the case, then we can just kind of invert that to say that sine theta is equal to root 3 upon 2. So we're now solving a much simpler problem. Now, of course, what a lot of students will do immediately at this point is say, okay, well then theta is equal to the sine inverse of root 3 upon 2. They'll put that into their calculator and they will get 60 degrees or pi by 3 radians. That's great, that's true, but the problem is it doesn't really give you all of the subsequent values, and you need those subsequent values to get the next couple of marks. So what's the best way? Well, before you do anything with your calculator, I suggest that you try to draw out the sine graph. Right, so if I draw out the sine graph, try to do it reasonably quickly, then what I'm going to get is I'm going to get something like this. So, oh boy, it's probably going to be a bit ugly, guys, but I'll try my best. Okay, something like that. Not great, not great, never mind. Going up, down, like that. Okay, something like that. And we know that this value here is pi, and this is 2 pi, right? Because one full sine wave takes 2 pi radians. And if we want to solve where sine theta is equal to root 3 upon 2, then what we need to do is we need to draw a line where y is equal to root 3 upon 2. So if I draw this line here, we'll draw that. Okay, this is the line y equals root 3 upon 2. Then the solutions to the equation sine theta equals root 3 upon 2 is given by the intersection points of the line and the curve, right? So it's given by that point there, that point there, that point there, and that point there. Now, okay, we can find the first of these points using our calculator, right? So we do our sine inverse, and that tells us that this particular value here is going to be equal to pi by 3 radians, okay? But now that we've got that value, how can we find this particular value here, right? What's that coordinate? Well, what we can do is we can use the property of symmetry. That is, we know that the sine graph is symmetrical about pi by 2 here, right? That is, that this point is a reflection of this point and vice versa. But it also means that this point here, where x is 0, or theta is 0, is also a reflection of this point here, where theta is pi. So this means that this distance here must also be the same as this distance here. Right? Let me just repeat that. The distance from here to here, that distance, is the same as the distance from here to here distance. Okay? So if this distance here is pi by 3, then this distance is also pi by 3. And so this coordinate is given by pi minus pi by 3, which is 2 pi upon 3. Okay, guys, so that to me is really important. I think you want to be able to understand where the other solutions are coming from, okay? You can use the quadrant method and do it, okay, fine. But I think really a good thing for you to do is to be able to interpret the graph and to be able to explain using symmetry how you get these the second value. Okay, well, now that we've got that, we actually want to find these values here and here. I want to find now this value and this value. Now, instead of using the property of symmetry this time, what we can do is we can use the fact that the sine wave repeats, right? It's a regular wave, so we've got one full wave here, and this repeats every 2 pi radians. We've got another wave here. Now, what that means is that this point and this point, they're kind of like identical points. This point is just one wave along from this point here. So in other words, if I took this point here, pi by 3, and I move one full wave to the right, one full wave, I'm going to end up at that point. Okay, so take this point, one wave, I'm going to move to this point. Well, how big is one wave? One wave is 2 pi radians. So if I take pi by 3 and I add 2 pi, I'm going to get to that point. And pi by 3 plus 2 pi is 7 pi upon 3. Okay, and I can do the same thing with this point here. Right, if I take 2 pi upon 3 and I move one wave to the right, so that means I add 2 pi. And what that's going to be is I'm going to get 8 pi upon 3. That's 8 pi upon 3. Okay, so now what I'm saying is we've got 4 solutions to deal with. Now, in other questions, you may actually have to keep going, right? So you need to keep adding 2 pi or actually go in the opposite direction and subtract 2 pi. But for this question, it's unnecessary. So what we've got is we've got 4 solutions to deal with. We have got our pi by 3 solution. We have got our 2 pi by 3 solution. We have got 7 pi by 3. And we've got 8 pi by 3. So these are all of our solutions if we're thinking about theta. But of course, we're not thinking about theta. We're thinking about phi, right? Remember back earlier in the question, I said let theta equal to 2 phi plus 3 pi upon 4. Well, now what we've got to do is we've got to go back. We've got to reverse that to find solutions for theta. So final step, if theta is equal to 2 phi minus 3 pi 4, was it minus? Let me double check, plus 3 pi upon 4. Then phi is going to be equal to theta minus 3 pi upon 4, okay? All divided through by 2. Okay, so what I've got to do is I've got to take each of these values here, okay? And I've got to subtract 3 pi upon 4, and I've got to divide by 2. Well, doing these fractions, which are thirds, minus this fraction here, which is a quarter, is probably going to be a little bit annoying, unless what I do first is I convert it all to the same common denominator. So I think that's probably what I'm going to do. So the common denominator will be 12ths. So this pi by 3 will be 4 pi upon 12. This one will be 8 pi upon 12. And this one here will be being rather silly, 28 pi upon 12. And this one here will be 32 pi upon 12. And so then instead of subtracting 3 pi upon 4, I can think of this as subtracting 9 pi upon 12. Right? In other words, what I've done is I've changed this into 12, changed these into 12 so then I can do the subtraction easily. Well, if I now do that, I'm going to take my first solution, 4 pi upon 12, and then I'm going to subtract 9 pi upon 12, so that's minus 5 pi upon 12, and I divide by 2, that's going to be minus 5 pi upon 24. Okay, now I do the next solution. I get my 8 pi upon 12, I subtract 9 pi upon 12, which gives me minus 1 pi upon 12, divide by 2, minus pi upon 24. Okay, then I take this one here, the 28 pi upon 12, minus 9 pi upon 12, which is going to give me 19 pi upon 12. And I divide by 2, 19 pi upon 24. And then lastly, I take this one, 32 pi upon 12. I subtract the 9, so that is 23 pi upon 12. Divide by 2, I get 23 pi upon 24. And those are my 4 solutions. Okay, so to recap, the method I strongly recommend that you use to try to solve these questions, number 1, is firstly, use a substitution, right? Immediately take a complex problem and turn it into a simpler problem. Okay? So we want to be trying to solve something like sine theta is equal to something, or cos theta is equal to something, or tan theta is equal to something. Then once you get to this point here, draw a graph. Draw out your graph, use the property of symmetry and repetition to find out all the solutions for your substituted variable. Then once you found all these solutions, then you can substitute back. And substituting back is going to be a little bit of work with fractions. That's okay though. So long as you're slow and steady, what you should do is you should get all of these right solutions. Okay, so I acknowledge this method is slow, I acknowledge it's a little bit cumbersome, but the point is it should always yield you the correct answers, and it should be something that you are able to understand. Always, always, always want to avoid in add math situations where you are basically guessing. Never want to guess. You always want to be able to reason out and to understand and to confirm to yourself you've got the right answer. Okay? All right. Okay, then we're in question 7, which is a permutations combinations style of question. We want to find the number of ways in which 14 people can be put into 4 groups containing 2, 3, 4, and 5 people. Now, generally speaking, the problem that people have with this type of question is they don't know whether or not to use permutations or combinations. And so what is the difference between these two things? Well, the essential difference is for permutations, order matters. Okay, order matters. But for combinations, order does not matter. Okay, now what does that mean? Well, let's take an example here. Let's say that we are choosing people to put into a group, and the people are John, Paul, George, and Ringo. If I chose those 4 people in that particular order, it would be the same thing as if I chose them in another order, right? If I chose George, Paul, John, and Ringo, or Ringo, George, Paul, and John, or Paul, John, George, Ringo, it doesn't matter which order I choose the people, I've still got the same 4 people in the end. So in this particular case, because the order in which I choose the people or the order in which they come to me doesn't matter at all, then what I need to use is combinations. Okay, need to use combinations. This is in contrast, for example, with a password. Let's say I was choosing letters for a password like the letters A, B, C. Say that's my simple password. Well, that would be a different thing to B, C, A. Right? Those two things are different there because order matters in a password. And so for that particular question, we would need to use permutations. Okay? All right, then. Well, let's return to the question. So we're using combinations. So first, you want to ask the question, how many ways can we choose 2 people from 14? The number of ways we can do that is 14C2. And then, having chosen 2 people, we've got 12 people left. And from those 12 people, we want to create a group of 3. Well, how many ways can we choose 3 people from 12 people? Well, the answer to that is going to be 12C3. Okay, well, now we've chosen 3 people. We've got 9 people left. And from those 9 people, we want to choose a group of 4. Well, how many ways can we choose 4 people from 9 people? It will be 9C4. And lastly, if we've chosen 4 people, then we've got 5 people left remaining. And so how many ways can we choose 5 people from 5 people? Well, that will be 5C5. Now, actually, you should notice that 5C5 is the same thing as 1. If you just think about it for a second, the number of ways you can choose 5 people from 5 people is 1. There's only one way to do it. Okay? Now then, the last part of this is we've got to multiply these things together. Now, this often causes people a bit of confusion. Am I multiplying? Am I adding? Now, here is a simple kind of rule of thumb. If you've got to have something and something, right, you've got to have 2 things together at the same time, then you multiply. If you've got to have something or something, then you will need to add them. Now, in this particular case, what we're saying is we want a group of 2 and a group of 3 and a group of 4 and a group of 5. We want all these things together at the same time, and therefore we are multiplying, okay? So if we were to expand all this, so we got 14C2, that's 91. And then we've got to multiply that with 12C3. So I'm going to write 12C3, which is 220. And then I've got 9C4, so 9C4, that is 126. And then 5C5, as I said earlier, is just equal to 1. So now I've got to multiply this all out. So I'm going to use my calculator. Okay, and what I get is 2,522,520. Okay, so that's going to be part A of this particular question. All right, and let's go to part B. Here we've got 6-digit numbers to be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 10 digits in total to choose from. Each digit may be used only once, and the 6-digit number must not start with a 0. And that's a very important thing. We must make sure that we acknowledge that statement. How many 6-digit numbers can be formed if there are no further restrictions? Well, I think the best thing to do is always to draw this out. So 1, 2, 3, 4, 5. There are 6 spaces here. And what we're saying is that the first number, there are 9 ways of filling it. Why are there 9 ways? Well, because we cannot have the 0. We can only have numbers 1 to 9. Well, now that we've chosen the first number, we've got to fill the remaining 5 numbers. Now, if we think about this, we have got 9 numbers left to choose from, right? Because we started with 10 and we've already picked 1. And we are choosing 5 numbers. So now we've got to do 9P5. Again, if I just take you back, why are we using permutations in this case? I take you back to part A. We're using permutations because in this case, order matters, right? If I was to choose the numbers, for example, 3, 2, 5, 1, that is going to be a different arrangement to 2, 3, 1, 5, right? Even though the numbers there are all the same, the fact that they're arranged in a different order is important, right? These 2 situations count as distinct outcomes. And therefore, because order matters, I'm going to have to use permutations. Okay, now then the last thing is, well, what do I do with the 9 and the 9p5? Am I going to add them or am I going to multiply them? Well, the answer is I'm going to multiply them. Why am I multiplying them? Because I want to choose this number here and these numbers here. I need them both at the same time. So I'm going to get 9p5 times by 9. And 9p5 times by 9 is 136,080. That's the answer for part 1. Okay, well, now we want the 6-digit number to be divisible by 10. Well, again, let's draw this out, I think. So 1, 2, 3, 4, 5, 6. Okay. And again, there are 9 ways of choosing the first number. And now if we want to choose the last number, well, the last number, right, it must be a 0. Because if it's divisible by 10, it has to end with a 0. So how many ways can I choose that number? There's only one way to choose that number, right? So there are 9 ways of choosing the first digit. There's only one way of choosing the last digit. Now, let's take the middle digits. Well, I've already used up 2 digits, so I've got 8 digits left to choose from, and I'm now choosing 4 digits. So the number of ways I can do that will be 8p4, right? Because I started with 10 digits. I've now only got 2 digits left. I've used 2 digits, so I've only got 8 digits left to choose from. And I'm choosing 4 from that 8. I end up with 8p4. Okay, and then again, I've got to multiply this out. So I'm going to have 9 times by 8p4 times by 1. What's that going to be equal to? Well, let's do 8p4. We're going to times that by 9. I get 15,120. 15,120. All right, then lastly, part 3. The 6-digit number is greater than 500,000 and it must be even. All right, well, again, what I'm going to do is I'm going to draw this out, right? 1, 2, 3, 4, 5, 6. Okay, now let's think what the options are. If the number must be greater than 500,000, then this has got to be either 5, 6, 7, 8, or 9. Okay? And if it's going to be even, then the last digit has either got to be 0, 2, 4, 6, or 8. Okay? Those are the options. Now, I think it's the best thing to do just to be nice and clear and systematic. And so what I'm going to do is I'm just going to cycle through all the different cases. And what I'm going to do is I'm going to think about the first digit. So if the first digit is, let's say the first digit is 5. Okay, now if the first digit is 5, how many ways can I choose that first digit? Well, there's only one way. Right? Why is there one way? Well, because I've already said, right, I'm just choosing 5. So there's only one way I can choose 5, and that's 5. Well, then how many ways can I choose this last digit? Well, there are 5 ways to choose the last digit because there are 5 numbers there to choose from. I'm going to multiply by 5. Then how many ways can I choose the remaining 4 digits? Well, I've got 8 digits to choose from. I'm choosing 4 of them. That's 8p4. So I'm going to times this by 8p4. Okay. Well, what if the last digit isn't 5? Let's say the last digit is 6. Then how many ways could I choose the first digit? Well, there's only one way of choosing 6, and that's 6. Now, how many ways can I choose the last digit? Well, remember, I can't have this 6 here anymore. In other words, there are only 4 digits here now that I can choose from, 0, 2, 4, and 8. So the number of ways I could choose the last digit this time is just 4. And then the number of ways I can choose the middle 4 digits, again, is 8p4. For the same reasons, there are 8 digits left to choose from, and I'm choosing 4. Next one, let's say I've got the first digit is 7. There's one way of choosing 7 to be the first digit, and there are 5 ways to choose the last digit, so I'm timesing through by 5, and I'm going to multiply that, sorry, not plus, beg your pardon. I'm going to multiply that through by 8p4 again for the 4 middle digits. Okay, so we've got 2 last alternatives to consider. If the first digit is 8, there's one way to choose the first digit. There are then 4 ways of choosing the last digit, right? Because I can't choose 8. What I've got there is 4 ways. And again, I've got 8p4 ways of choosing the middle. Lastly, if the first digit is 9, there's one way I can choose 9. There are 5 ways I can choose the last digit because I can have any of these here. And there are 8p4 ways of choosing the middle digits. So you get 8p4. So what I've got is, I've got 5 lots of 8p4, 4 lots of 8p4, 5 lots of 8p4, 4 lots of 8p4, and 5 lots of 8p4. What am I going to do here? I am going to add all of these. I'm going to add all of these things here. Now, why am I adding? Well, if I take you back to what I said earlier, so part A, I think it was. Where was it? Right here it is. I multiply when I want to have something and something at the same time. I add when I've got this or this, right? In other words, I add when I've got alternative cases to consider. So I could have this situation where the first digit is 5, or I could have this situation where the first digit is 6, or this situation where the first digit is 7, or this situation, right? It can be either this, or this, or this, or this, or this. And because it's or, I need to add, right? So if I do that, I am going to end up with, I've got 3 5s, right? 15, and 2 lots of 4 is 8. So I'm going to have 23 lots of 8p4. And if I push that into a calculator, 8p4, I times it by 23, what I end up with is 38,640. Now, listen, guys, what I'm saying to you is That may not be the fastest way of doing it, and I'm sure if you look at the mark scheme, it seems like they create numbers. It seems like almost out of thin air, and it seems incredibly simple and short. And you always want to have a short, simple answer. But with these questions, I think the key for understanding is to just cycle through all the different alternatives. You need to be at a point where you can explain to yourself your method for going through this question. Are you being slow, methodical, meticulous? I think if you can do that, then these questions, which are usually very hard, begin to become quite straightforward. But it's a test of your patience, I think, more than anything. So do not try to be fast at the expense of getting it right, right? If getting it right means you slow down and you consider all the cases and you can understand it and explain it to yourself, then that's the thing you want to aim for, because ultimately I think that's the thing that will help you to be successful. Okay, I hope that was helpful, guys. Okay, guys, so here we are in question 8, which is a functions question. It is given that f of x is equal to 2 ln 3x minus 4 for x is greater than a. We want to write down the least possible value of a. Now, essentially, you just need to know this. You need to know that the input for the ln function, this thing here, must always be greater than 0. Okay, so it can't be equal to 0, it can't be less than 0. So we're going to state that 3x minus 4 must be greater than 0. And so therefore, x must be greater than 4/3. That means that a is equal to 4/3, or that is the least possible value of a. Next, we want to write down the range of f. Well, again, this is really about understanding what the ln graph looks like. What does a ln graph look like? Well, I'll draw the graph of ln x. Okay, the graph of ln x looks something like this. Oh, no, wait, sorry. That. Something like that, where that coordinate there is 1. And what do we mean by range? Well, range means all of the possible output values. Well, I can go from negative infinity all the way up to positive infinity, and I've got valid output values for my function. So we can say that the outputs for the function can be anything from negative infinity all the way up to positive infinity. But a much nicer way of writing that is to say that f is the set of all real numbers, right? In other words, it can be any real number. Okay, so this is part C of our functions question. It is given that the equation f of x equals f inverse of x has two solutions. What that means is that the function and its inverse are going to overlap at two places. We want to use our answer to part A to sketch the graph of f of x and f inverse on the axis below. Well, let's just state what the function is. So the function was f of x is equal to 2 ln 3x minus 4. Sorry, let me just double check that and make sure I'm remembering right. Yeah, 3x minus 4. And what we said is that, well, this graph must always be greater than 4/3. So if I was to draw 4/3 on here, so let's say 1/3, 2/3, 3/3, 4/3, then our graph must always be greater than 4/3. So I'm going to draw that asymptote on like that. Okay. And we should also be able to find out what the x-intercept of our graph will look like. Now, there's a shortcut way of doing this. You can say that the x-intercept is found by setting this value here equal to 1. If you're not absolutely sure about why that is, I'll just do it nice and slow. The x-intercept is when y is equal to 0. We're solving 0 is equal to 2 ln 3x minus 4, which means that we're solving 0 is equal to ln 3x minus 4. And then we can convert to exponential form. We get e to the power of 0 is equal to 3x minus 4. Which means that 1 is equal to 3x minus 4, right? So in other words, if we want to find x-intercept, basically we set the thing inside the log equal to 1. Well, if we rearrange that, then we're going to get that x is going to be equal to 5/3. Okay? So we get 5/3 is where our intercept is going to be. So let me just draw on 5/3 there. 5/3. So our graph is going to go through that particular point. Okay, so we're looking for a function that's going to come up here, it's going to cut through there, and it's going to go up like that. Now then, we also know that our inverse function is going to be a reflection in the line y equals x. So I think I'm going to draw the line y equals x on this your graph like that. So here's the line y equals x. We know that our inverse function is going to be a reflection in that line. Okay, y equals x. And furthermore, we also know that therefore our reflected line will have a reflected asymptote and a reflected intercept. So we've got 1, 2, undo that, sorry. 1, 2, 3, 4, 5. So 4/3 is going to be our asymptote, the inverse function, like that. And the y-intercept will be 5/3 there because it is a reflection of that point, right? So in other words, this x-intercept is a reflection to give that y-intercept, and this asymptote here is reflected to give that asymptote there. Now, the only other thing we require is that these two graphs are going to overlap twice. So that means they've got to cross the line y equals x twice. So here and here, let's say. So now I'm going to try to draw this graph. It's probably going to look a bit ugly. Never mind. So we're going to go up through there. Beg your pardon. If I go through here, I'm going to come through here, and it'll do something like that. Sorry, that's a bit exaggerated. Okay, and then the other graph, same thing. It's going to come up through there. We'll cut through here at the same point. Cross back over and cut through there. Okay, so there we are. We have shown our graphs. We've shown the asymptotes. We've shown where it crosses the x and y intercepts, and we showed where they kind of overlap each other through the line y equals x because these are inverses. All right, I hope that was helpful. Okay, so then part D of our functions question, we are given that g of x, a new function, is equal to 2x minus 3. I want to find an expression for g of x. Well, this is a composite function, isn't it? What it really means is we substitute 2x minus 3 into the function 2x minus 3. So g of x is going to be equal to 2 bracket 2x minus 3 minus 3, right? In other words, every place where I've got an x in here, I replace it with the function 2x minus 3. So if I expand that, what I'm going to get is 4x minus 6 minus 3, which is 4x minus 9. Okay, then hence we want to solve the equation fg of g of x is equal to 4, giving our answer in exact form. Well, this is basically saying we want to find f of g of x. There's another composite function. We're finding f of 4x minus 9. Now then, we need to remember what the function was, right? F of x was equal to 2 ln 3x minus 4, okay? And so what we're going to do is we're going to substitute in 4x minus 9 into this function. So we're going to get 2 ln, big bracket, 3 times by 4x minus 9 minus 4. Okay, we're going to set this whole thing equal to 4, right? So we're saying 4 is equal to 2 ln this whole equation here. Well, let's expand. We're going to get 12x minus 27 minus 4. Okay, we'll divide both sides through by 2, so we're going to get 2 there is equal to ln 12x minus 31. And then we can convert to exponential form. So if we convert to exponential form, we're going to get e to the power of 2 is equal to 12x minus 31. So therefore 12x is equal to e squared plus 31. And therefore x is equal to e squared plus 31, all divided through by 12. Okay? Okay, here we are in question 9. We've got a curve, which is given by this particular equation here. We've got a straight line, which is given by that equation there. We've got to find the area of the shaded region. Okay, now then, when students do this, they say to me, this is an integration question. And they are right. We are going to have to integrate. But instead of categorizing it in your mind immediately as an integration question, I think the first thing you want to do is to say, this is actually just about finding the area. And so if I want to find the area of the shaded region, then really what I've got to do is I've got to find the area of 2 other shapes. So I've got to find this area here is the area underneath the curve, that area there, which I will refer to as area 1. So that's 1. And then what we've got to do is we've got to find the area underneath the line, which is this thing here. Ooh, different color. Is this thing here, which is basically the area of a trapezium. And I'm going to call that thing area 2. So the way we want to think about this question is we are finding area 1 and we're finding area 2. Okay, and then we are finding the difference between them. Now, in order to be able to do that, we need to know a couple of other pieces of information. First of all, we're going to need to know this y coordinate there. All right, well, that y coordinate is essentially the y-intercept of this particular equation. Okay, and we're going to need to know this x coordinate here, and we're going to need to know this coordinate here. Okay, so our first job is not really doing any integration, it's finding those coordinates. So let's take the first one. Let's take this guy here. This guy is the y-intercept of our straight line. So y-intercept is when x is equal to 0. So we take our equation 3y equals 2x plus 6, and we substitute x is equal to 0. We get 3y is equal to 6. We get y is equal to 2. So what we've just learned is that our y-intercept there is 2. So that coordinate is 2. Okay, well then let's try to find this point of intersection. Well, how are we going to find a point of intersection? What we've got to do is we've got to do some simultaneous equations. So what we're going to do is I think I will substitute this equation here into this equation here. So I'm going to say we're going to have 3 times by 3 plus 4 upon 2x plus 1 is equal to 2x plus 6. And so I'm going to expand this. I'm going to get 9 plus 12 upon 2x plus 1 is equal to 2x plus 6. And then I'm going to, I'll subtract the 9, I think, from both sides first. So 12 is equal to 12 upon 2x plus 1 is equal to 2x minus 3. And I'm going to multiply through by 2x plus 1. So I'm going to get 12 is equal to 2x minus 3, bracket, 2x plus 1. So now I've got to expand this quadratic. I expand the quadratic, and what I'm going to get is 4x squared plus 2x minus 6x minus 3. And so if I simplify everything, I'm going to get 4x squared minus 4x, and then minus 3 minus 12 is minus 15. Well, okay, I've got to then solve that quadratic. So I'll probably try to solve it using factorization, I think, hopefully. Okay, and if I use factorization, I think I'll do 2x and 2x there. And I'm looking for two numbers that have got to multiply out to give negative 15. That are going to combine in such a way that I get negative 4 here. Well, I think probably those numbers have got to be 5 and 3. And so if I put here negative 5 and positive 3, I'm just going to check if that works. Well, negative 5 times by positive 3 is negative 15. Here what I'm going to get is 2x times by 3, which is 6x. And then I'm going to get 6x, and minus 5 times by 2x is minus 10x. So 6x minus 10x is negative 4x. So that works. We've got two solutions, which is x is equal to negative 3 upon 2, or x is equal to 5 upon 2. Well, which one of those are we interested in? Well, if we just look at our graph, right, obviously we're interested in the positive value. So this is the coordinate 5 upon 2, the x coordinate 5 upon 2. And we can find the y coordinate as well just by substituting into our line. So what I can do is I can say, I'll go over here, when x is equal to 5 upon 2, 3y is equal to 2 times by 5 upon 2, which is 5, plus 6. So y is going to be equal to 11 divided by 3. So this y coordinate here, that one there, is 11 upon 3. Okay, so now I think we've got all the information that we need. Well, first of all, what should I do? I think I'm going to find the area of the trapezium. Now, the area of trapezium is going to be a half of this length plus this length times by this width here. So I'm just going to move across to the right. So the area of trapezium, so area 2, is equal to a half of 2 plus 11 upon 3 times by the width, which is 5 upon 2. So let's try to simplify that. First of all, I'm going to get 5 upon 4 times by, if I do 2 plus 11 upon 3, that's going to be 17 upon 3. Okay, and that's not going to simplify very nicely. So 5 times by 17 is 50 plus 35, that's 85 upon 12. All right, so the area 2 is 85 upon 12. All right then, so now what I've got to do is I've got to find the first area, area 1. The way I find that area is by integrating this curve here. Now, notice actually I've done a lot of work before I even get to the point where I have to integrate. So this question is, in a way, not really an integration question. Integration is only a part of it. Okay, so I'm going to integrate 3. Area 1 is equal to the integral of 3 plus 4 upon 2x plus 1, I think. Is that right? Yep. dx. And I am integrating that between 0 and 5 by 2. Now, if I integrate 3, I'm going to get 3x. If I integrate this thing here, I'm going to get a ln 2x plus 1. I take the coefficient of the x, which is 2, and I divide by 2. So that's going to be my integral. I'm doing that between 5 upon 2 and 0. Now what I've got to do is just got to substitute in. So I'm going to get 3 times by 5 upon 2 is 15 upon 2 plus 2 ln 2 times by 5 upon 2, which is 5 plus 1, so that's ln 6. And then I've got to substitute in 0, so 3 times by 0 is 0, plus 2 ln 2 times by 0 is 0, plus 1 is 1. And of course, ln 1 is equal to 0. So this whole thing is 0. So what I'm left with is 15 upon 2 plus 2 ln 6 is my integral. 15 upon 2 plus 2 ln 6. So what is my total area going to be? My total area, so shaded area, is going to equal that thing, which is 15 upon 2 plus 2 ln 6 minus the area of the trapezium, which is 85 upon 12. So minus 85 upon 12. And I can probably simplify this a little bit. So 15 upon 2, I'll times top and bottom by 6. That'll be 90 upon 12 minus 5 is 5 upon 12 plus 2 ln 6. And does it ask us to give that answer in a specific way? Let me just double check what we're asked. 1 second. No, that's perfectly adequate. We can leave our answer as 5 upon 12 plus 2 ln 6, or if you prefer 5 upon 12 plus ln 36. All right then, so here we are in question 10, which is an arithmetic geometric progression style question. We're told that the first 3 terms of an arithmetic progression are 2x plus 1, 4 times 2x plus 1, and 7 times 2x plus 1, where x cannot be equal to negative a half. Now, if you think about that, that's kind of obvious, because if x is equal to negative half, then each of these terms is going to be 0. Okay, we want to show that the sum to n terms can be written in this form, where a and b are integers to be found. Now, because we are dealing with an arithmetic progression, the first thing we need to identify is a and d, right? That is the first term and the common difference. Now, the first term is going to be very easy. It's given there. So the first term is 2x plus 1. And the common difference, well, we can find the common difference by taking the second term and subtracting off the first term. So if we've got 4 lots of 2x plus 1 minus 1 lot of 2x plus 1, then what we've got here is 3 lots of 2x plus 1. Okay? All right, then, if we want to find the sum of the first n terms, then at this point we just need to use the formula for the sum of the first n terms, which is Sn is equal to n upon 2, 2a plus n minus 1 d. And so what we're going to do here is we're just going to substitute in our value of a and d into this expression. So let's do that. What we've got here is n upon 2 bracket 2x plus 1 plus n minus 1 times by 3 lots of 2x plus 1. Now, notice that I did not expand this thing here. Now, why did I not expand it? Well, because hopefully you can see that we're going to get 2x plus 1 as a common factor, right? So we've got a factor there and a factor there of 2x plus 1, which means that we can factorize this whole big bracket. So let's do that. I'm going to get n upon 2, 2x plus 1, a big bracket 2 plus 3 lots of n minus 1. In other words, basically, you don't really want to expand unless you really have to, because you make your life more complicated. You want to keep things in factorized form because it helps you to simplify. Okay, so now if I do this, I'm going to get n upon 2, 2x plus 1, and I'm going to have 2 minus 3, which is minus 1, plus 3n. So this is 3n minus 1. And therefore, I think we've got it in the form that's asked in the question. In this case, a is going to equal to 3, and b is going to equal to negative 1. Okay, let's do part 2. We're given that the sum to n terms is now equal to this thing here. So we want to find the value of n. Well, we've already found an expression for the sum of n terms, which is this thing up here. Now we can just set it equal to what we've got. So why don't I write that down? We're now saying that n upon 2 bracket 2x plus 1 times by 3n minus 1 will be equal to 54n plus 37 times by 2x plus 1. Well, okay, you should be able to see that we can divide both sides by 2x plus 1. We can cancel both sides. So that's gone. That's gone. And so what we're left with here is n upon 2 bracket 3n minus 1 is equal to 54n plus 37. Now, I want to get rid of the fraction on the left-hand side, the n upon 2. So what I'm going to do is I'm going to times both sides by 2. So n bracket 3n minus 1 is equal to 108n plus 74. And on this side, I expand the bracket. 3n squared minus n is equal to 108n plus 74. And then I can bring everything through to one side, which gives me 3n squared minus 109n minus 74 equals 0. Now, at this point, you can probably use your calculator to factorize. I think this one's quite hard to factorize by yourself. I'm going to try to do it anyway. But if you don't know how to use a calculator to solve quadratics with coefficients a, b, and c, then I strongly recommend that you learn how to do that. You ask someone to teach you, because it'll just make your life a bit easier in an exam. But nevertheless, I will try to factorize anyway. I know that I'm going to have 3n and n here, so that I get 3n squared. And then I need to find two numbers that are going to multiply together to give negative 74. So one's got to be positive, one's got to be negative. And I think maybe I'll try 37. And I've got to choose them in such a way that I'm going to end up with minus 109n. So if I just try that, if I put negative 37 here and positive 2, then what's going to happen is I'm going to get 3n times by negative 37. Well, that's going to give me minus 90 minus 21, so that's minus 111. And then I'm going to get plus 2n here, which is minus 109n, right? So that all works out. So what that means is we end up with two solutions, right? We've got n is equal to minus 2/3, or n is equal to 37. Well, we just got to think about it, right? We can't have n is equal to minus 2/3, okay? Because it's an arithmetic progression, and what n stands for is the number of terms, right? So you can't have a negative number of terms, and you can't have a fraction number of terms, right? You can either have a first term, second term, third term, and so forth. So this solution here, we need to exclude it and say we're not interested. So the only answer that we want is n is equal to 37. All right, let's go down to part 3. So given also that the sum to n terms in part 2 is equal to 1017.5, what we want to do is to find the value of x. Well, okay, then we're just going to set it equal, aren't we? So 54n plus 37 times by 2x plus 1, let's do that. So 54n plus 37 is equal to 2x plus 1. Make sure I got that right. Oh, times by 2x plus 1, beg your pardon. Yeah. Correct that. Times by 2x plus 1 is equal to 1017.5. All right, then. Well, we learned in the previous question that n is equal to 37. So what we've got here is we've got 54 times by 37 plus 37. Well, that's actually the same thing as 55 times by 37. Right? So 55 times by 37 times by 2x plus 1 is equal to 1017.5. Well, then let's just multiply that out. I'm going to do 55 times by 37. So 55 times by 37 is equal to 2035. And so if I divide by both sides by 2035, I'm going to get 2x plus 1 is equal to 1017.5 divided by that, and that's equal to a half. Now, that's a nice answer, isn't it? So I think we can probably assume that we're on the right track. All right, then let's rearrange. We get 2x is equal to negative a half, and therefore x is going to equal to minus a quarter. Okay, so that's our answer for part 3. Okay, then part B of this arithmetic geometric progression style question. What we've got here is a geometric progression with terms 2y plus 1, 3 times 2y plus 1 squared, and 9 times by 2y plus 1 cubed, where y cannot equal to negative half, again, because if y is equal to negative half, then each of these terms is just going to be equal to 0. Okay, we're given that the nth term of the progression is equal to 4 times the n plus 2th term. We want to find the values of y, giving our answers as fractions. Now, listen, guys, really the key to doing this is being able to interpret this sentence here and just going through it nice and slow. So what we want to do is we want to find an expression for the nth term of the progression, and then we want to find an expression for the n plus 2th term, and then we can set the relationship between them where the nth term is 4 times the n plus 2th. So let's try to do that. Now, before we start, if we've got a geometric progression, we need to know 2 things. We need to know the first term, and we need to know the common ratio. Okay, now the first term is easy, right? That's given to us there. That's 2y plus 1. And then the common ratio, well, the way we can find the common ratio is to look at any 2 consecutive terms. And what we do is we do the latter term divided by the former. So I'm going to take the second term here, I'm going to divide it by the first. So if I do that, I'm going to get 3 times by 2y plus 1 squared all over 2y plus 1. And what you can see is we can divide top and bottom by 2y plus 1. So we cancel. And so the common ratio is just equal to 3 bracket 2y plus 1. Okay, then, we need to know the formula for the nth term of a geometric progression. So un, the nth term, is equal to a times by r to the power of n minus 1. Now, guys, a really important thing, this power n minus 1 is just for the r. It's not a times by r, the whole thing, the power of n minus 1, because that would be that in brackets, okay? That's a very common mistake. What you've got to do is you've got to do r to the power of n minus 1 and then times the whole thing through by a. All right, so let's try to plug these numbers in. So we're saying that the nth term is equal to a, which is 2y plus 1, times by r, which is 3 times by 2y plus 1, all to the power of n minus 1. Okay, and remember that 3 there has also got to be raised to the power of n minus 1. So if you don't put a big bracket round here, number 1, you're wrong, but number 2, also you're going to forget to raise that to the power of n minus 1. All right, let's simplify this. We are going to end up with here 2y plus 1 to the power of 1 times by 3 to the power of n minus 1 times by 2y plus 1 to the power of n minus 1. Now, we can combine these two things, this thing and this thing, and we can use the indices rule. Right? If we've got a to the power of x times by a to the power of y, that's equal to a to the power of x plus y. We add the indices. What I'm going to do is I'm going to take 1 here and add it to n minus 1. And 1 plus n minus 1 is just n. So what we're left with here is 2y plus 1 to the power of n times by 3 to the power of n minus 1. Okay, so that's that. Okay, well then the next thing we want to do is we find the n plus 2th term. So we're going to do basically the same thing. Un plus 2 is going to be equal to the first term a times by r to the power of n plus 2 minus 1. Okay, so let's substitute our terms in. What we've got is a is 2y plus 1 to the power of 1. Our r is 3 times by 2y plus 1 to the power of, well, n plus 2 minus 1 is n plus 1. Now we're going to expand all this again. So we will end up with 2y plus 1 to the power of 1 times by 3 to the power of n plus 1 times by 2y plus 1 to the power of n plus 1. And again, we can combine those two things, this and this, by adding the powers. So what we end up with here is 2y plus 1 to the power of n plus 2 times by 3 to the power of n plus 1. Okay, so what we have, just to summarize so far, is we've got an expression for the nth term, and we've got an expression for the n plus 2th term. Okay, so that's down there. Now, if we go back to our question, what was the relationship between those two things? The nth term is equal to 4 times the n plus 2th term. Okay, so just go back. We're saying that this thing here, that thing, is equal to 4 times that thing. So let's write that down. So 2y plus 1 to the power of, what was it, power of n, times by 3 to the power of n minus 1, double check that again, yeah, is equal to 4 times 2y plus 1 to the power of n plus 2 times by 3 to the power of n plus 1. All right, now, at this point, what we're going to do is just going to do some division. We are going to divide both sides through by this term here on the left-hand side. So I'm going to divide everything through by 2y plus 1 to the power n times by 3 to the power n minus 1. So if I do that on the left-hand side, I'm going to get 1. On the right-hand side, I'm going to get 4 times by 2y plus 1 to the power n plus 2 divided by 2y plus 1 to the power of n times by 3 to the power of n plus 1 divided by 3 to the power of n minus 1. All right? Now, why have I written it like that? Well, because now we can use another indices rule. The indices rule, if I've got a to the power of x divided by a to the power of y, what I do is I subtract the powers. I get a to the power of x minus y. So I can do that with these terms here and also these terms here. So therefore, what have I got? I've got 4 times by 2y plus 1 to the power of n plus 2 minus n. And n plus 2 minus n is just 2. And then I've got times by 3 to the power of, I'm going to write it out slowly, n plus 1 minus n minus 1. Now, if you're not sure, then just do everything nice and slow, right? It's better to do it slow and get it right than to try to be quick and make a mistake. All right, then. Let's try to simplify this. So I've got 4 times by 2y plus 1 squared times by 3. Well, I've got n minus n. So that's going to cancel off, chop, chop. I've got 1 minus minus 1, which is 2. Okay, all right then. So now let's try to simplify this. I have got 1 is equal to 4 times by 9, which is 36, times by 2y plus 1 squared. Now, what I could do is I could expand all this, make it into a quadratic and simplify, but I think there's a simpler way. I'm going to divide both sides through by 36. So I get 1 upon 36 is equal to 2y plus 1, 2y plus 1 squared, beg your pardon. And then if I square root both sides, what I get is 2y plus 1 is equal to plus or minus 1 upon 6, right? So if I square root 1 upon 36, I get a sixth. And I've got to remember to have plus or minus. So then 2y is equal to minus 1 plus or minus a sixth. Okay, well, I'm just going to slow it down at this point. I'm going to say, therefore, I've got two options. 2y is either equal to -1 plus a sixth, which is -5/6, or 2y is equal to -1 minus a sixth, which is -7/6. And so therefore, y is equal to -5/12, or y is equal to -7/12. And those are my two final answers. Okay. Now, guys, I just think it's helpful just to review how we've done this. I really, really think the key to success with these kind of questions is you got to break it down, right? So notice how I didn't jump directly to this thing here, right? I wasn't trying to be too clever. What I did first is I found an expression for un, then I found an expression for un plus 2. I simplified both of those, and then did I combine them. Okay, so I think one of the things that you need to learn very often is just patience, right? Break down a big problem into smaller problems and just make sure that you're slow, that you're meticulous, because ultimately you want to make sure you get it right, not just that you do it quick. Okay, I hope that was helpful, guys. Okay, then, so here we are in 10C, which is the last question of this paper. It's quite a demanding question in many ways, and I think it's designed really to distinguish between the A and the A-star candidates. Let's try to break it down. We've got the first three terms of a different geometric progression are sine theta, 2 sine cubed theta, and 4 sine to the power 5 theta. For theta is between 0 and pi by 2. We want to find the values of theta for which the progression has a sum to infinity. All right, now, first things first, if it's a geometric progression, we need to write down the first term, and we need to write down the common ratio. The first term is easy. That's given to us in the question. That's sine theta. Okay, sine theta. And the common ratio, well, the common ratio is you take any two consecutive terms, and you can do the latter divided by the former. So I'm going to take the second term, I'm going to divide it by the first term. So if I've got 2 sine cubed theta and I divide it by sine theta, I'm left with 2 sine squared theta. Okay then, well, what's the condition for a sum to infinity? The condition for a sum to infinity is that the common ratio needs to be between -1 and +1. Okay, now that's really the key fact you need to know in order to be able to do this question. If you don't know that fact, you can't do the question. Why is this the case? Well, if you think about it, if your common ratio is between these two values, then what it means is every subsequent term in your progression is going to get smaller. Because if you think about it just for a second, let's say we've got first term 2 and a common ratio of a half, then the next term is going to be 1, the next term is going to be a half, the next term is going to be a quarter, and the next term is going to be an eighth, and so on, right? In other words, all of these terms are going to get smaller and smaller and smaller, right? So instead of growing, the terms are going to get smaller. And if that's the case, if I add up all the terms, then what's going to happen is eventually I'll be adding something close to 0. And if I take something and I add 0, then that sum is not going to grow, which means that the sum reaches a certain limit value, that it can't grow anymore. Okay, so for those of you who didn't understand what sum to infinity meant or why this condition is true, I hope that was helpful. For those of you who already knew that, sorry for the diversion, but I think it's important, right? You need to grasp the concept. Okay, so returning to the main question, basically what we are being asked to show is that this common ratio satisfies this condition, or rather to find the values of theta for which this common ratio satisfies this condition. Now, let's just think about it. It doesn't matter what theta is. Sine squared theta will always be greater than 0. Why is that? Well, because if I take any number, whether it's positive or negative, and I square it, then what I get is a positive number. So automatically, we already know that r must be greater than -1, right? Because actually we know that r is greater than 0. So we don't have to worry about this side of the inequality. All we've got to worry about is we've got to worry about this side. So we've got to try to find the values of theta such that 2 sine squared theta will be less than 1. All right, well, let's just rearrange this then. This means that we want sine squared theta to be less than a half. And if this is the case, if we square root both sides, we're going to end up with the following inequality, that sine theta must be between -1 upon root 2 and +1 upon root 2. Now, if you're not sure about that, then I suggest you go back and you review your quadratic inequalities. You can imagine for the second you replace sine squared theta with x. You've got x squared being less than 1. All right, and if you just think about that, you draw out the graph, and what you see is that means that x must be greater than -1 and less than +1. All right, but I don't really want to spend too much time thinking about that right now. So we want to find theta such that sine theta is going to be between these two values. Now, how can we do that? I think the best way is always to draw a graph. Let's be nice and meticulous about this. We're going to draw out our sine theta, which is going to look something like this. Do beg your pardon in advance for the rubbish graph. Okay, like that. Like that, like that, like that, like that. Ooh. Like that, like that. All right. Okay. And so this will be pi, this will be pi by 2, be minus pi by 2, and so forth. Okay. And then what we want to do is we want sine theta to be less than 1 upon root 2. So we can draw a line where y is equal to 1 upon root 2. So that'll be like that. And we want it to be greater than minus 1 upon root 2. So we can draw a line where y is equal to minus 1 upon root 2. So if we got that, this is plus 1 upon root 2. This is minus 1 upon root 2. So what we're saying is we want our values for sine theta to be in this region here, right? We want it to be between these two values. The question is, well, what x coordinates give us that? Well, we can now use our calculator. We can find that the sine inverse of 1 upon root 2 is going to give us 45 degrees, or pi upon 4. And conversely, if we're minus 1 upon root 2, the sine inverse of that will be minus pi upon 4. Okay, so the values of theta which satisfy this inequality are the values of theta between here and here. Right? In other words, what we've got is theta. This means that theta is greater than minus pi by 4, and it is less than pi by 4. But remember, if we read the question, very carefully, theta is between 0 and pi by 2. So actually, we're not even interested in this part, right? So that part we're not interested in. All we're interested in is the bit between 0 and pi by 4. So in the end, our final answer should be that theta is between 0 and pi by 4. Now, guys, again, as with lots of these questions, you can see that I've spent quite a bit of time answering it. It's only 3 marks, and the mark scheme just says, do this, do that, do the other, and bish, bash, bosh, you've done with the question. Again, with all these things, it's really important that you can actually understand it, right? And you want to be able to explain it to yourself. And I think sometimes just being nice and slow and careful helps with that. And again, I know I say this again and again and again if you listen to my videos, drawing a graph, I really think this helps. Okay, if you can visualize what's going on, then I think you've got a much better chance of understanding it. Okay, well, I hope that was helpful, guys, and good luck with all the other papers. If you found these videos to be helpful, please do like, please do subscribe, please share them with your friends. Good luck, and I hope you do well with Add Math.